The nominees for the 22nd CISC Ontario Steel Design Awards in Engineering are redevelopment of the Toronto Sun Media Site. The redevelopment of 333 King Street in Toronto offered multiple design and construction challenges. Structural steel simplified the build and made it feasible. The ability to reinforce the existing steel columns through the existing floors and carry the required new forces down to new foundations was a key element to carrying out the design. The Abilities Center. The Abilities Center is a 130,000 square foot therapeutic, recreation, and community complex designed to be fully accessible, projecting strength, pride, and athleticism. Steel was chosen for its flexibility with various geometries, angular, orthogonal, and curvaceous, providing a distinctive, bold, muscular form that has become the symbol and the brand of the center. The Algonquin Center for Construction Excellence. Algonquin College's objective was to create a teaching facility that would position them as leaders in technical education and provide students with hands-on learning experience akin to what they will encounter in the real world. The structural engineering services were part of a highly collaborative design and construction team, creating a hybrid structural system in an exposed building environment, utilizing steel along with other building materials. In addition to the time-saving advantage that steel offered for the classroom tower, it also resulted in significant material savings. Detour Lake Gold Mine Project. With more than 15.6 million ounces in reserves, the Detour Lake Gold Mine Project is on track to become Canada's largest operating gold mine. Steel was the obvious solution due to the project's fast-track nature and the building's considerable height and span. The use of steel was all the more appealing as it could accommodate possible future changes to the structure. Environment 3 Building, University of Waterloo, EV3. The EV3 building provided unique design challenges. The restricted site, the university's ring road, and the existing building all played a part. Steel was the only option, as the majority of the structure could be manufactured off-site, and site and soil conditions required unique foundations. They were designed in tandem with an ambitious steel skeleton. Where possible, the structure was left exposed, leaving one constantly aware that in EV3 they are supported by steel. Maintenance Hangar 1, Canadian Forces Base, Trenton. The project's mandate was to provide economic, suitably sized and equipped facilities to accommodate maintenance requirements for the Canadian Forces' new larger aircraft. The choice of steel provided numerous benefits, including speed of construction, lower project costs, design flexibility, sustainability, and aesthetic appeal. With approximately 3,000 tons of steel used, the project was completed on time and on budget. Redecking and widening of Hogs Hollow Bridge at Highway 401, Toronto. The redecking and widening of Highway 401's Hogs Hollow core structures is one of the largest bridge engineering projects using primarily structural steel in recent years. With a total of over 1,200 tons of high-grade 350 WT steel used, the installation was completed amidst the busiest traffic conditions in the country, with minimal disruption to the road users. The innovative solutions and careful sequencing of the works were key, allowing the completion of the project over 1 year ahead of schedule and within budget. Highway 17 Westbound Lanes Bridge over the Madawaska River. In twinning this 310-meter bridge, unique challenges in design and construction include the length of the bridge, the transportability of its fabricated sections, potential structural fatigue due to its size, its proximity to the Ontario Power Generating Station near Arnprior, and its location in Ontario's highest seismic zone. Kitchener Memorial Auditorium. Home to the Kitchener Rangers OHL team, the Kitchener Memorial Auditorium was built in 1949. The expansion added 3 levels, working around the OHL hockey season, allowing a construction time frame of 7 months. Structural steel was chosen, as it could be fabricated off-site and erected quickly during the off-season. A structural steel truss and open-web steel joists were chosen for the roof because of their excellent span-to-depth and span-to-weight ratios, providing column-free spaces with unobstructed sightlines. Loblaws, and Ryerson University redevelopment of Maple Leaf Gardens. With the Toronto Maple Leafs move to the ACC in 1999, it left the iconic Maple Leaf Gardens vacant. In 2003, Loblaws purchased the building to create a multi-level retail store, and in 2009, Ryerson University partnered with plans to create a new athletic center. As a heritage building, the redevelopment needed to ensure the preservation of the historically significant elements. Offering many design and construction challenges, structural steel provided stability, reinforcing and shoring and permitting the long spans without temporary shoring in the new building, allowing the construction to proceed simultaneously in multiple areas. Ripley's Aquarium of Canada. Close cooperation across the design and engineering teams enabled the production of this highly complex and irregular structure. It also allowed the engineering team to visualize the individual steel members in the context of the entire structure during the shop drawing review process. The large quantity of steel that is exposed both to the eye and to the environment required the design of connections that are aesthetically pleasing and complemented the architectural form. Parade Sky Bridge. Structural steel was the only material up for the challenge of providing the structure for the Sky Bridge. Perched between the two high-rise towers and suspended 30 stories above ground, the structure was assembled on the ground and erected using a strain-jacking technique. From the exterior, the visible truss members contribute to the overall architectural expression of the form and its relationship to the adjacent towers. University of Windsor Ed Lumley Centre for Engineering Innovation. A flagship facility designed to encourage collaboration and promote creativity, where students can learn from the exposed structural, mechanical, electrical, civil, and environmental engineering systems that are displayed throughout. 10-meter-high structural steel T-sections were designed as a grillage to optimize weights and distribute loads. Intermediate horizontal steel angles were eliminated through the installation of stainless steel rod rigging lateral cross bracing, resulting in a naturally lit two-story circulation space, which uses the performance of steel to maximize glass exposure and daylighting. Once again, we're proud to present the nominees for the 22nd Annual CISC Ontario Steel Design Awards in the area of engineering.